All right, recording is rolling. It's the last 10 minutes of class, so let's put some of these graphs together. We'll probably have to finish this up exactly tomorrow morning, but we'll just get start here. All right, so let's start with time period and mass. So who was in a group who was changing out the mass? Okay. But Elijah, what were your what were your masses?
We tested each mass twice. Our masses were 500 grams, 200 grams, and 100 grams.
Okay, and then you tested one of those twice?
Yeah.
Okay. And what were the corresponding time periods?
But for 10 intervals, it was 15.5,
Yeah, but what about just the time one?
1.55,
Okay, so 1.55 for 500 grams?
Yeah.
Okay.
1.56 for 200 grams,
6.
1.54 for 100 grams.
All right. So you guys can probably just see at a glance just from the table. What do you guys think the relationship is between those two? Say,
The relationship?
there you go. No relationship, right? Because here, from the smallest one to the biggest one, mass goes up by a factor of 5. And time period, it's just a matter of like experimental error, right? Okay, so let's graph this thing. Okay, so time period versus mass. You guys know to put time period in seconds on the vertical axis and mass in grams today and on the horizontal axis. Okay. I meant to mention too. I know some of you guys like to keep a lab notebook. If you want to do this in your own lab notebook, that's all right too. But just a tiny graph here. Okay, so masses go up to 500 grams. We got a scale that's axis 0. Let's go about 100, 200, 300, 400, 500. That's one way to do it. Okay. And then the time period hovers about 1.5 seconds. So let's go 0, 1, 2, 0.5, 1.5. Throw in the middle there. Okay. That should contain all the data, right? Okay. Okay. So 100 grams, we're looking at 1.54. That's right about there. Bam. 200 grams, 1.56 seconds. Bam. 100, yeah, all right. 500 grams is 1.55 seconds. Bam. Now, based on a bunch of these that I've seen in the past, and maybe some of you guys today, sometimes you might have, this graph looks pretty flat, right? So, line of best fit, flat. You can say there's no relationship between those two variables. So you change out the mass and nothing happens to the time period. But you know what? I think that is consistent with a story that you guys have seen all along in this class. You guys know that classic Galileo story, runs to the top of the Leaning Tower, drops a couple objects, different masses, and they fall at the same rate. Okay? So different masses have different weights, but also different inertias, but those two effects cancel each other out. A equals F over m, Newton's second law of motion. Okay. Well, if you just tag it to a pendulum, it's the same principles. Okay? So yeah, the larger masses will have more weight, but they'll also have more inertia. Those two effects cancel out, and you guys just showed that empirically. Okay? Now, going back to what I was about to say. So, what I've seen from some past labs, sometimes you might have a slightly upward slope on this graph, slightly upward slope. Did you guys get that? Okay. So, if you change out the mass, now why would that be? Why would you possibly have a slightly upward slope?
Could be rocking this thing more, causing it to lose energy.
Maybe something like that. Yeah, maybe if you put on more mass, maybe it changes this. It causes the ring stand like rock back and forth. Possibly something like that might throw it off. Okay. I think the main reason most of the time is that if you tag on larger masses, if you have here, guys, if you go from this to this, do you guys see how the center mass is actually a different location? Do you think you would effectively make this pendulum length a little bit longer? And maybe length, that's a different variable, right? So sometimes if you don't control for that exactly, then that can throw that off a little bit. Okay. All right, let's go on to next group. If you had the diamonds, who is it? Who is changing out the angle? Wants to share their data. All right. So Nicholas, what were your different angles?
We started at 15 and then changed the angle by adding 5.
All right. So 15, 20, 25?
Yeah.
So 15 degrees, 20 degrees, 25 degrees, and then like 30 degrees and 35 degrees.
Yeah.
Okay. All right. So let's go with those 5. What were your time periods?
So for 15, we had 1.48.
1.48,
20 was 1.44.
4.44.
25 is 1.42.
Alright.
30 was 1.44. And then 35 was 1.43.
All right. So again, at a glance, what do you guys think the relationship is between these 2 variables? Okay, it looks like no relationship again. Okay. All right. So okay, let's graph this thing. So we got time period in seconds here. We got angle and degrees here. Okay. So the time period covers around the second half. So 0. So 1, 2, just like before. Still the same. Okay. Degrees. We've got 0. See, 10, 20. 10, 20, 30. Yeah, we can do 5 degrees at a time. 5, 10, 15, 20, 25, 30, 35. I'll fit in there. All right. So 15 degrees was at 1.48. Bam. 20 degrees, 1.44. Bam. 25 degrees, 1.42. Bam. 30 degrees, 1.44. Bam. 35 degrees, 1.43. Bam. Yeah, so you can see at a glance, it's going to be no relationship between those 2 variables either. Okay. All right, well, we got 1 more to go, and I made it a big graph, so this is probably the one that actually does matter, right? Okay. All right, so if you guys had the spades, all right, let's go time period in seconds here. We'll go length of the pendulum and, because we've got centimeters, so. Okay. All right, who wants to share their data from change out the length? All right, Leonardo, what were your different lengths?
21 centimeters, 29 centimeters, 41, and 56.
All right, so let's go 0. How about let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, how about that? That'll work. 55, 60. Okay, should pay all the data there. All right. And what was your longest time period?
Our longest was 1.63.
1.63. So 0. Okay. 3, 5, 6, 7, 5. Let's go 1, 2. Well, what did I just do? I don't know. Okay, we'll this work. All right. So, all right, what was one of your XY coordinates? So your shortest length and the corresponding time period?
So it was 21 centimeters and then 1.05.
0.05. All right. So that's right about there. Bam. And what's the next one?
29, 1.178.
1.178. Right. It's right about there. All right. Next one.
41, 1.363.
1.363. Somewhere around there. 35. All right.
56, 1.63.
1.63. All right. Yeah, I scaled this badly myself. Should have done this a little differently. But okay. You guys can see at a glance that the longer the pendulum, the more time it takes to swing back and forth. Okay, I see that. All right, so there's some kind of upward trend there. Now, bell's about to ring, so we're gonna have to save this for tomorrow. But what exactly is that relationship going to be? Is it going to be a direct relationship? Is it going to be maybe a square root relationship? You guys think about that, and we will finish this tomorrow. So hang on to that page. Okay. Guys, double check your grade on focus. If there's anything that's, if you got like a 69, 79, 89, and you want to raise your grade a bit, go check your grade book. I'm still taking stuff.